Okay, so this location, we're not going to be here a long time, so kind of budget yourself based on what we're going to tell you to do here. This is one of the stops, but I don't know if anybody noticed the red rocks as we were coming up before. We didn't see any for a while, and then we got into this ridge. So these are hogbacks. Which I'll draw out what that is later. But we're in the Madison limestone. And so the Black Hills are that way. We just came out of Rapid City. So if you want for a location, you could call this Roadside Stop, west of Rapid City. Madison Limestone, mile marker 57, Highway 16. West of Rapid City. Highway 16, mile marker 57. There's a mile 57 over there, there's a mile 57 over there. Okay, so what we're going to do is we're going to do an outcrop sketch of that side. But before we do that, what are some observations that you see over here? Okay? Okay, yeah, there's some borings here for the blasting with the road. Slanted which way? Okay, so hold that thought. It's dipping. It's not slanting, it's dipping. Generally this direction. Jessica noted there's kind of a weird bowl shape. There are, on this side, that's why we're all going to get different rocks. And the outcrop is a little convoluted, it's nice on that side. There collapse structures and dissolution features. So the Madison limestone will be important for Aaron. It's going to be obviously super important for Laura. You'll see that over the next couple of days. You don't have to worry too much about that. But what other observations can we make here? We have to dip, we have convolute, bedding, colors, yeah, changes in colors. What else?
There's some layering.
Okay, you can talk about the different layering. It's the dipping planes are the bed separations, and the beds are different, right? Well, that kind of goes along with what you were saying.
Roadside stop west of Rapid City. Highway 16.
What about the texture?
Mile marker 57. And we put road cut into Madison limestone.
So the point is that there's a lot of change here. There's a lot of observations to make. So you can describe the color. You can describe up the bedding. This side you would spend like 3 hours doing that. But let's take a look on that side. So on this side, what you're going to do while we're here, we're going to take about 15 minutes. You're going to do a sketch and a description of that outcrop. So when you're doing field work involving description of broad features, there's basically 3 steps. You would ordinarily start roughly this far from the outcrop of interest, and the first thing you almost always do is provide a large sketch of the entire thing. And the goal of a sketch is not to draw every minute detail, but rather to draw a broad cartoon representation of the important features, right? As a suggestion, the best way of doing it is to look at this real quick. Like everybody look at the outcrop over there and picture in your mind the full outline of the rock. And it should be just this giant lens shape, right? So in your head, picture a line that goes across the top and then stretches along the road back to where you started. That's all you need as an outline. You don't need to draw the road. You don't need to draw the trees. We don't care unless we're here to study the road or to study the trees, right? We care about the outcrop, the rock. Next, what do you notice? Okay, Dr. Frederick already pointed this out. Things that are very important are thicknesses of layers and orientation of layers. Other features like joints may be important, but if you look at that kind of jumbled area up there, do we need to draw every single one of those blocks? No, because it doesn't matter. You might want to do a cartoon representation of how blocky that is, but that doesn't mean standing here and exactly drawing every one of those. But you can picture how you could use symbology to represent that without having to draw it. Okay? So what you want is to look at it and think orientation and thicknesses. And just like before, this is thinly bedded over here. It's more massive over there. Do you have to draw every thinly bedded layer? No. No, not unless you see something that is worth emphasizing. Okay? So you could draw a general depiction of this whole outcrop in a minute or two, because there's not a whole lot of specifically interesting stuff in it that isn't hard to draw, right? There is lots of interesting stuff in it. You can just represent that with a cartoon very quickly. It's all about cartoon, right? We're not trying to make a photorealistic sketch. So don't get hung up in like the details of these little soil thingies and fractures and whatever. First draw the outline, then a cartoon representation. And at the end, every sketch needs a title, it needs compass orientation, it needs a scale. You're going to estimate the vertical scale. It needs labels and sometimes very brief descriptions. Anybody that's had my intro course, that probably sounds like the concept sketches we do, and there's a reason for that. Okay, because all sketches get labels and brief descriptions and a title and a scale and a compass orientation. Okay, what way is that way? That way is northeast. So at the top of your profile, you can draw an arrow that way that says northeast and an arrow that says southwest. If you're looking to the north, don't draw an arrow up and label it north, because that would mean that way is north. And that way is not north, that way is up. Okay, you can write view to the north, right? Or in this case, view to the northeast. Yeah. You write that. Yeah. You can say view to the southeast, or you can label the right.
Yeah, label it. That side is northeast, and that is south.
That's better.
Southwest.
Yeah. Okay.
You should do this in landscape. I know some of you started already. Oh, the other thing, before I forget. Ooh, I need one here. A piece of paper. When you're sketching, oh, yeah, and I know a lot of you started. When you're sketching, bold lines. Commit. We commit to our lines in this class. None of this, oh, it's kind of like that. No, you look at it, you picture it, and you put an intentional line. I like this line. I'm drawing it for a reason. If you do a lot of this like back and forth kind of, I'm not committing, that means you might not even need the line. Okay? Bold lines. I can unbury everything from this mess. Okay, look at the lines in this sketch from last year. Look at it. No wavering. Line. None of, here, let me see. Like that stuff, avoid that. And I'm not like picking on anybody. Yeah. But when you come in and you draw this and you're like doing this. Well, which line is it? Okay, that's no good. What you want to do is look at it, and if I'm drawing that profile, I say, oh, it kind of does this, and then there's like one of these, and then it's this way. Boom. Which one of those two is better?
Dark.
Dark lines. Does everybody see that? So we'll say, no. Yes. Okay. See the difference? Commit to those lines. Yeah. That's the goal. There's not much to draw here. If you're looking at that and saying like, oh, I should add more, no, you probably shouldn't, because there's not a whole lot of stuff to cartoon represent, right? But once you get it, once you get that sketch, then you walk over to where we are like here, and look at the difference between what you can pick out here versus what we see from this distance. If you were to walk over there, you'd see stuff like this, and then you walk to a stop on your sketch, and you find something and you label where you are on your sketch, and you'd, like if you saw this, you'd put a little dot there, and you'd say, the spot on my sketch right here corresponds to stop 2, where you make your closer descriptions.
We are not going
We're
over
not doing
there,
that.
though. We are not going over there, so don't take that as license to cross the road.
No. That's just why you would make this, so you have a reference frame to match your field descriptions. And that's why you do the far away sketch first, to provide context for your notes. Title, scale, map directions, labels, and brief descriptions. Brief descriptions being 4 or 5 words. So a label would be, you know, if you see a deep red coloration, you could put a little line, deep red. Okay? The brief descriptions often come from getting a little closer. So don't worry so much about that. But you might have a brief description of this block here, right? Composed of several squarish blocks, maybe a meter wide.
I use the term annotation.
Yeah.
You've heard me say annotation. That's basically a label.
Yeah, labels.
Okay?
Yeah.
But just don't. Generally, labels are like. Oftentimes people think of a single word as a label. That's not necessarily what we're talking about here. It can be like you can put like a little mini description as an annotation, or it can just be a single word.
What? Yeah, northeast is that way. Southeast, southwest. Northwest, northeast, southwest.
If I were drawing that.
Yeah, so like that is a 19-foot box truck.
80-foot. Okay, so that van is probably 15.
Yeah, that's what I was figuring out.
That's a 19-foot.
So yeah, 60. It depends on where you're stopping. It could be deep by, okay, well, that truck is probably 12 feet.
What's the name of the limestone?
Madison line.
Madison.
250. You don't need that down here. Yeah, this is the like. Yeah, just the vertical scale's fine. You don't always need a horizontal. That's why it's helpful to know your pace if you were really doing some detailed work, which we're not.
I'd say this is, I mean, it's really,
I said 250 to 300. And just so if you're wondering how we're estimating this stuff, watch this truck go by. Maybe that truck is 15 feet wide, long. Just get that length and keep building it. So 30, 60, 120, 240, 300. Yeah, and you can look at cars go by for height too, right? Picture yourself standing by this truck. That truck's probably what, 10 foot? 12 foot? Yeah. Yeah, right? And then just build it up.
I said like 40 to 80.
It's an estimate, right?
Yeah, 40 to 80. I originally had like 80 to 100, but then I saw it more and I was like, yeah, I'm doing.
So here, you're going to want to like label why you put those lines. That's something you would ordinarily. But yeah, I mean, I see.
How do you feel like
Recently.
I could
Yeah,
make
the
out
length.
maybe.
It's about like
Yeah, that's what
50-ish feet tall. I said 40 to 80.
Massive one. There's the really well, that's all stone. I'm sure you can buy that. And then you get these
no, I mean, don't change it, but that's what he was talking about committing. It's like, you start this feathering of lines and then you're just darkening your feathered lines. That's not. We're asking you to like
see the difference between sketching like that or like that.
Mm-hmm. I started doing that before you.
Right, I know.
Before you
People were
started
sketching before we got the way through, which is fine. This is
learning.
So all of this is line good. I don't like that.
This is something like this is
You
weird.
see how it's kind of
so
feathery?
that would help.
That helps drive home the pointer. So if I would do it,
I would go over to the other side and try to figure out, is that really there? Or you walk in that direction and look at it from a different angle, and it might look different. You might recognize it. It's actually just wet. And so it's looking different because it's a darker color.
I just want to avoid stuff that looks like this. And then a label, yeah, the label helps. Totally fine. You would usually put it above the outcrop, but this is fine.
I'll take this.
Yeah, totally.
Yep.
Yeah, we're just out in the public realm.
Yeah, there's really cool stuff. Yeah, it's everywhere. I have a like a fossilized coral I pulled out of here. Oh, look at that! That's like cool. That's cool. Rocks.
Before I came on a geology course, I was.
It's dirty.
Like if you can find lots of pockets of really nice fish.
That's
That's a good one. Yeah, I have a huge block of it. That's a really good one. Oh yeah. Look at that skin. Woo! Is there? Oh yeah.
We were explaining
That's such a good question. I got a great question. Should you write like a number or estimate the actual dip here? Do we see the dip? The true dip.
yes,
You said no. Somebody said no. Why? How do we know?
because we have the strip.
Or technically, maybe. No? Well, we don't have the strike, right? How about this? Can I stand here with my compass and do this and say that's the true
because you need
dip?
to be touching the water.
You have to be against it and measuring it. But why? Why can't I stand here and say that's dipping
Because that's just like objective.
18 degrees? No, I measured it. It is. The plumb bob said it's 18 degrees. That doesn't matter because this.
The ground you're standing on could be tilted one way or
It
another.
doesn't matter. I used my compass from here.
But you're not level.
It doesn't matter. Gravity is always down, and the plumb bob points down.
Yeah, this has a level in the plumb.
Yeah, there's a plumb bob in here, and it always points exactly down, no matter what. So it doesn't matter how I'm standing.
Okay.
It's pointing down, and it says 18 degrees. Is it 18 degrees?
I don't know.
But why do we not know? My thing says it is. There's a problem in structure, and it's called the difference between apparent dip and true dip. If I'm holding my hand like this, watch how I can keep this edge of my hand unmoving, but change the plane. See how this finger isn't changing? Any of these dips could cause that appearance in cross section, but we don't see the plane. We just see lines where the rocks are coming out of the ground, and they could be going like this, or they could be going like that, and we don't know until we go over and measure. If you look at these, you can see that plane is actually kind of going this way, which means it's not going like this, it's going like this. Can everybody see the underside of this thing? See how it's kind of like this? That means the true dip is like that way. Right? It's not like this, it's like that. Right? So you can estimate, you could say the apparent dip is 18 degrees to the whatever that was, northeast or whatever, I forgot.
I don't even know if my drawing's decent or not.
North. Yeah. It's approximately 18 degrees to the northeast. The apparent dip is, but you have to get to the outcrop to actually describe the orientation.
Dr. Harris, could you say like from a distance that's what you observe, and then as you get closer,
Yeah.
you're like, okay.
Yeah, so these would be outcrop scale descriptions. Apparent dip of 18 degrees to the east. And that can be useful because you can determine the true dip from two apparent dip measurements. You know, you put it in your bag, it'll probably end up as it looks good, but you have a lot of breakups. I would recommend someone that's simply because that gives you the appearance of dip. Just in the future, I would use symbols other than lines, because this kind of looks like herringbone or cross beds. I don't know many symbols. Just use like dots or circles or something.
I can do that in the future.
Okay. No, I understand what you're saying. That's really good.
Yeah, but the way we're still
All right. So that thing would be perfectly horizontal, because if we're looking at that outcrop, according to this, northeast is that way.
Okay.
Because it's up in the air. So like flatten it out. It should be like straight horizontal.
Let's prepare to leave. So the Madison limestone has a lot of dissolution features in it. What do we call dissolved limestone terrain or features?
We talked about this in that van. Karst? Hey!
Yeah. So one of the things.
Woo, that's
One of
cool.
the
What do
things
you-
that Jessica pointed out is this big blob here, and you can see more continuous bedding over there. But right behind where Lauren and Aaron are sitting is this weird kind of blobby, inconsistent shape. You see the same thing over to the right. As the karst is developing, you can get large-scale collapses into those cavities, and then that can become an area where you get crystallization occurring and kind of almost re-cementing. So this side is really convoluted because the bedding has been disrupted by these collapse structures. But on the other side, we don't really see those. Consistent. Wildly different
Karst is like
appearance.
the topography of by
In the
dissolved
water
limestone.
that was reprecipitating minerals after this filled in, what was the chemistry of the water? It had iron in it. That's why this is all orange. All right, let's start heading back. Oh yeah. Yeah, these
What is this?
calcite spikes are really
It
cool.
was a
Yeah, I think it was on my shoulder.
You got any idea what this is?
I really want to take this, but this is a huge rock. Andy, are you trying to pick one of the really nice crystal one? Here, I got you. Here. There you go.
bigger than expected.
That is a lot larger than I expected it to be.
Yeah, me
but
too.
I found this.
We don't need one.
I don't know what it is.
Probably like 15, 16, 24.
Of the Black Hills?
Yeah.
No.
Hey, who's going
these are dipping-
prospecting for gold in the Black Hills?
These are the dipping layers away from the central crystal material. And this is one of the most valuable. It's really easy to identify because it looks like this. It's got these beautiful crystals. It's a really, really thick limestone
As
layer.
long as it's family-friendly geology puns, we're good.
Because it's like, oh, there's an ash. You know exactly what I'm going to
I said I was like looking at it. On this side, like it goes like this way, and then like it goes like